Hey everyone, and welcome to another Blender Geometry Nodes tutorial. If you enjoy Synthwave, Retrowave, or retro-styled visuals like these, you're in for a treat. In this video, we'll create an animated neon retro landscape and explore a few simple tricks for animation and composition. First, open up Blender 3.5 or any other version with the Geometry Nodes feature. Delete the default light, create a new collection, and drag your default cube in there for convenience. Head over to the Geometry Nodes tab and, with the default cube selected, create a new Geometry Nodes configuration. We'll start by disconnecting the base geometry and adding a grid mesh primitive, which is basically a plane. Grid node gives us control over its size and the number of vertices, and we can see that better in the Wireframe view mode. Let's add X and Y size values to the group input so that we can easily control the grid size from the modifier properties. Head over to the group settings in the panel to the right to change the input data types, default values, and validation rules. I want to make these integer values to have a fixed step when resizing. To ensure the number of vertices increases as we change the number of cells in the grid, we'll add 1 to the X and Y inputs and connect them to the grid vertices sockets. This way we can control number of cells in the grid with size X and size Y inputs, like so. For now, let's set the grid size to 20 by 20. Let's set up our camera. Navigate through the scene to find the best camera position. Then press Ctrl-Alt-0 to place the camera based on your location in the scene. You can make any additional adjustments to the camera location and rotation as needed. Also, reconfigure the grid size to match your scene. I'll resize mine so that the grid edges are out of the camera viewport. Now it's time to create an endless movement for our grid. And the easiest way to do this is to endlessly move each vertex point. So, add Set Position node, which allows us to offset vertices of the mesh. The Scene Time node will come in handy here. If we connect the seconds or frames output to the offset socket of the Set Position node, we'll achieve a continuous motion when playing the animation. To make the grid move in the Y direction only, we'll use the Combine XYZ node and put the scene time value into Y socket only. This way our grid will move endlessly in one direction. Now we would like to create a looped movement. To achieve this, add a Math node after the Scene Time node. Select the Wrap operation and fill in maximum and minimum values. In my case, I'm using a range from 0.5 to -0.5, which is basically a range of 1 in total and equals to the size of a single cell of the grid. Next, we'll add 2 Math nodes. The first one will multiply the scene time by -1, creating a movement in the opposite direction. The second one will multiply scene time by a value that will serve us as the speed multiplier. Add this multiplier to the group input to control speed outside of the node tree. Default value of 4 looks fine to me. Now let's create some mountains for our landscape. What we want to do is to displace the vertices of the grid along the z-axis. So add another Set Position node. This time let's use a texture to drive the offset here. Musgrave texture node is one of my favorites in such cases. Connect the texture's height output to the Set Position node's offset socket. Right now, the displacement happens in all directions. Use a Combine XYZ node to restrict the offset to the Z-axis only. Here you can change different parameters of the texture, like scale or detail, but if you set it to 4D, you'll have additional W setting, which will work like the variation or seed. Once you find the best configuration for the texture, add a color ramp node to control the texture levels in between the texture and set position nodes. To adjust the height range, use a map range node, where you can set the lowest and the highest points of the point's displacement. Let's play the animation. You may notice that mountains do not move with the grid, and to make them do so, we need to do a bit of math. Each texture has a vector input. Add a vector math node and connect it to the texture. Select the add operation for this vector math node. The displacement disappeared. To fix it, we need to add a value to each point's current position. So let's add position input node, which corresponds to point's position. Now we can add value to point's position on X, Y, and Z value. Use a Combine XYZ node and connect our scene time value along with the speed multiplier to its Y value. Let's see how it looks from the camera and adjust grid dimensions if needed. In many retro video sequences, there's often a road in the middle of the scene. To create this effect, let's remove some displacement in the middle of the texture. The best way to do this is by mixing textures. Let's try gradient texture on the grid. Add a mix node between the color ramp and Combine XYZ node. And set the data type to color, since textures are basically colors. Select multiply operation or experiment with other operations. Set the factor to around 0.95 to not completely remove the displacement in the road. Plug the gradient texture to slot B. Now the level of the gradient texture to off. Let's add a color ramp to define the lowest and the highest points, which are black and white or 1 and 0. To adjust the texture's position, add a vector math node and set the operation to add. Connect a position input node as the first vector and set X to a negative value to adjust the position of the gradient texture. Maybe add Combine XYZ to have a separate input for X value only. To create the same effect on the opposite side, duplicate the entire gradient texture setup. Combine these two setups using a mix node with the add operation selected. This time use a positive value for X in the vector math node. The second texture may need some rotation. Luckily, we have vector rotate node. So let's rotate texture 180 degrees on Z. I want to control the width of the road from the outside of the node tree. So I'll add this X value to the group input, name it road width. And multiply this value by -1 for the first texture. Nice, and it works with different grid parameters. On the top of the landscape, it will be really cool to have a grid that will have a shape of the landscape. We can get this effect by adding a wireframe modifier, but there is an easy way to achieve this with geometry nodes. Now first, let's convert the mesh to a curve with mesh to curve node. We've got the grid, but it's not going to be visible in the render. So we need to make it solid and convert it back to mesh with curve to mesh node. The curve to mesh node allows us to specify a profile curve, so let's add a curve circle node and connect it. Decrease the resolution and radius of the curve circle so they make sense. I'm using a circle radius of 0.01 meters with a resolution set to 4. The landscape now appears see-through, so we'll use the join geometry node to combine the converted and original landscapes into a single mesh. Next, add set material nodes to both the landscape and the converted landscape. Create and select materials for each. Now, before we start working on the materials, there is a really cool way of passing color information from geometry nodes to materials. So let's add group input node and add 2 inputs with color data type and name them accordingly: ground color and wireframe color. Plug these 2 from group input into group output. In the modifier properties, there is a section called output attributes. Assign attributes to each of them. I'll call mine G color and W color. In the shader editor, add a node called attribute. Copy the name of the needed attribute into the same field and connect color to base color and emission and principled BSDF. Now we can change the color in the geometry nodes modifier and use it in the material right away. Bump the emission strength up to have a nice glowing effect. Now repeat the same steps for the other material, just with a different color. Since we're in the shader editor, let's change the background color to dark blue by selecting World from the dropdown here and adjusting the background material accordingly. In the render properties, we'll keep the engine set to Eevee and enable ambient occlusion, and the most important option, bloom. There is a range of settings that will affect the result in render, so you may tweak those if needed. Press F12 to render the image. Close it and then switch to the Compositing tab. Let's add a few effects to make our render stand out even more. First, add a viewer node to see real-time results. You can change the size of the render preview using the zoom value in the view menu. Next, add a lens distortion node with the jitter and fit options selected. Feel free to experiment with the distort and dispersion values. For me, values of 0.02 and 0.025 work best. Add a glare effect with a high level of quality and adjust the color modulation, mix value, and other settings as needed. Keep in mind that you'll need to render the image or animation for these post-processing effects to be applied. They don't work in the viewport, even in render view. A common feature in many Synthwave videos is a shiny sun in the background. Let's add one to our scene. Create a mesh circle with the Ngon fill type. Join it with the rest of the geometry using a join geometry node. To rotate the circle, use a transform node and set the rotation on the x-axis to 90 degrees. Now we want to place the sun outside of the grid. At the same time, if we change the size of the grid, the sun should be positioned accordingly. To do this, use translation in the same transform node. Now since we have vector input for the translation, let's use combine XYZ node to have control over each axis of the geometry position. We already have information on the length of the grid in the group input. So let's take the size Y input and plug it into the Y socket of the combine XYZ node. Since the grid is located at 0, we probably need to divide it by 2 with math node. And now, the position of the sun is adjusted based on the grid size. Add a small value, like 2, to create some distance between the sun and the grid. Another thing that is going to be important is to control the size of the sun. So let's add mesh circle radius value to the group input and name it accordingly. To have sun shape smoother, you may use subdivision surface node. This will subdivide the circle and bring more vertices into the geometry. Let's assign a new material to the sun, and the process is going to be the same as before. Set material node with the new material selected, add another color value to the group input and output, which is going to be used as an attribute in the shader editor. I feel that the orange color is going to look nice here. Now let's run animation and take a look at the result. We may finish our project right here. But there is another common feature to include, which is endlessly moving stripes on the sun. I've decided to approach that with cutting some parts of the circle mesh while moving them on z-axis. So the first thing we may want to do is to add curve line. It will give us some points to instantiate some shapes. For now, I'm going to join it with the rest of the geometry to see what's going on. The length of the curve needs to be 2 times bigger than the radius of the sun circle. So, use the sun radius and multiply it by 2 with a math node. We also want this curve to have the same location as the sun. To achieve this, add a transform node and connect a combine XYZ node to the translation socket, using the same value from the Y location as we used for the sun. For Z location, multiply radius by -1. This calculation will give us a negative value, which will place the beginning of the curve below 0. Now we can use the points of this curve to instantiate some meshes. Add an instance on points node with the curve we just created connected to the points input. For the instance, let's use a cube mesh with the number of vertices for each side set to 2. To create more instances, resample the curve and specify the number you need. For the size, add a Combine XYZ node, which allows us to control each individual axis. For the X value, we want it to be 2 times bigger than the radius of the Sun, maybe even slightly larger. Multiply the radius of the Sun circle by 2. Set the Y value to 1. For the Z value, we may want to control it from the modifier properties. Use a mesh boolean node to cut parts of the Sun circle mesh. Select difference in the mesh boolean node and plug the Sun into the mesh 1. To animate this, use a set position node for the curve that used for the cube instances. Add a Combine XYZ node to the offset socket, since we want to make an offset only in the Z direction. To make the animation loop, use the wrap method in the math node, in a similar way that we used for the grid. You can take a complete setup that we used for the grid with those scene time nodes, the multiplier, and the group input right here, and reuse it for the wrap operation. And adjusting values in wrap operation will make the stripes movement smoother. Or you can even make this value adjustable based on the parameters of the Sun size. Just divide size height, which is radius multiplied by 2 by the number of stripes. Divide this number by 2 since we need only half of that for maximum value. And use the same value multiplied by -1 for a minimum value. Or vice versa, it doesn't really matter. Now, if you want to do even more, you can even bake some sounds into the animation. A good candidate for this will be the height of the mountains. Find the value that determines the mountain height, which in this case is the Musgrave texture. We previously added a map range node to control the height range of the mountains. Add another map range node and plug its result into the previous map range node with desired minimum and maximum target range. The value of this new map range node will go into the group input. Next, go to the Animation tab. At the beginning of the animation, click on the little dot in the modifier properties, which indicates that the property is animated. Open the graph editor and select that geometry node input. From the menu, go to Key and select Bake Sound to F Curves. This will allow you to select a track. In this case, I'm going to use a Synthwave track that I wrote some time ago. Once the sound is baked, if you want to check if the sound is synced, you can add a track in the video editing workspace. Now you're ready to preview the entire animation and render it. And that's all. Thank you so much for your attention. I hope you found this tutorial useful. I'll include a link in the description where you can download the project file from itch.io. Thanks again, and see you in the next video. Goodbye.